Okay, here's question 13 on this gases sheet. It's got a little bit of everything in it. 13 is some stoichiometry involving gases. So here's your reaction. This is octane, which is gasoline and gasoline burning. Burning an oxygen, making carbon dioxide and water. So there's your mole ratios in there. I'm going to walk through some of these. Some of them I'm going to go through fairly quickly. This was when you have 350 grams of octane, so you got 350 grams of this that are burning. So how many liters of oxygen would be used with it? But you're not an STP, so we cannot use 22.4 liters. So I'm going to start stoichiometry, work my way to moles of oxygen, plug in a PV nRT. So 350 grams of octane. Octane is 114 grams per mole. Mole ratio, 2 moles of octane for every 25 moles of oxygen. If we're at STP, I would just do every mole of oxygen is 22.4 liters. We're not, so we need to stop right there, get our moles of oxygen, which is 38.4 moles of O2. So if we burn 350 grams of propane, we need 38 moles of oxygen to burn with it. Now we can plug those into PV equals nRT, plug those in for moles, and we're going to solve for our volume. Your pressure is 740 millimeters of mercury. Remember, you need to take 740 and divide it by 760 to get into atmospheres. And don't forget your temperature needs to be in Kelvin. Answer there is 980 liters of oxygen. I'm not going to plug, I can do all the math there, but answer ends up being that. Next one here is telling you have 75 liters of oxygen available to burn. How many grams of carbon dioxide could be made? So if we started with 75 liters, I immediately would want to go 22.4 liters equals a mole. I can't do that because you're not an STP. So you're going to start with PV nRT. So plug in 75 liters. Plug in your pressure, which is 1 atmosphere. Solve for moles. R is 0.0821. And temperature 273 plus 35 would be 308. So we get our moles, 2.97 moles. Here's a key. That is not moles of carbon dioxide. It was liters of oxygen, so that is moles of oxygen. So people tend to think that. Now I do my stoichiometry saying, okay, we have 2.97 moles of oxygen. Now I can work from oxygen to CO2. So do my mole ratio, which is 25 moles of oxygen to 16 moles of carbon dioxide. If it wants grams, I can do a mole of carbon dioxide is 44 grams. That ends up being about 83.6 grams of CO2. All right. Let you figure out letter C. Actually, C is a liters to liters problem. C is liters to liters, so I'm going to do that real quick because you can save yourself some time here. So I'm going to go, you have 100 liters of carbon dioxide. Since the temperature and pressure are not changing, I can just do a liter to liter ratio. So we're going from carbon dioxide to oxygen. So I can say for every 16 liters of carbon dioxide, normally I'd say 16 moles as a mole ratio, there's 25 liters of oxygen. As long as they're at the same temperature and pressure, liters are synonymous with moles. You know, if I have a liter of carbon dioxide and a liter of oxygen, it's the same number of moles if they're at the same temperature and pressure. So we can just do a mole ratio there and get an answer. It's 156 liters of oxygen.